All right, so for balancing, what we're going to be doing is we're going to be counting the elements. Obviously, you have to identify them. So we got K and BR, and then we want to figure out how many of each we got on the left and the right side. So I'll go through these quickly. You got 1, 2, 1, 1. And then you want to make sure that you guys have the same number of bromine on the both sides. So we're going to add some to the side with fewer, so the right side. So we're going to add the entire molecule KBr. That's going to change us to 2 to 2. And then we got to balance the K by adding some to the left side. And then we can just add a K, and that gets us to 2. So your coefficients, numbers in the front will be 2, 1, 2. Okay. All right. I know I sped through that. Any questions? Hopefully it's not too bad. I know we've been practicing balancing for a bit, but I did want to go over it still. Okay. All right, let's go on to the next one. Next one's also pretty simple. We got SB and oxygen. So we're going to be counting them. So 1, 2, 4, 6. We need to add SB and oxygen to both sides. So let's start with the SB. So we need 4 on the left side. So we put a 4 right here. And then we need to add more oxygen to the left side as well. So we add them 2 at a time. So that's going to be 4. That's going to be 6. So the coefficients will be 4, 3, 1. Okay. Alrighty, so just to let you guys know, these two problems should have been pretty easy. Just relatively on your exam at the end of this unit, which will be right before Thanksgiving break, you can expect balancing about this difficulty. Okay. Was it? Yeah. So the beginning ones, I try to start you guys off easy, and then it'll get harder. And then, yeah, the previous assignment was a bit harder. It's harder than these ones. Alrighty, guys, let's move on to the new material. So I want you guys to write the title of the lecture. It's called Molar Mass. Okay, so write down the title of the lecture. It's called Molar Mass. And we're going to be talking about a very important concept in chemistry today. And you guys need your periodic tables. Just make sure you guys have your periodic table handy today. All right, so molar mass is important in chemistry because it's a way that we use to measure how much molecules and atoms, how much they weigh. Okay, so before we get into that, we need to talk about a different concept first. So I'm going to scroll down. And if you guys take a look right here, we're going to go through a couple things before we jump into talking about molar mass. So just based on our personal experience, if you have a dozen of something, how many do you have? 12. Yeah. If I have a pair of something, how many do I have? 2. If I have a trio, 3. And in chemistry, we use something called a mole to measure stuff. So it's not that ugly animal that lives in the ground. In chemistry, a mole is a way to count something. So just like how we can use a dozen to count 12 at a time, a pair to count 2 at a time, in chemistry, we count things 1 mole at a time. Okay? So if you have 1 mole of something, this is how many you have. Okay, so jot that number down. 1 mole of something, thank you. Okay, 1 mole is when you have 6.02 times 10 to the 23rd of something. And if you don't remember scientific notation from math, it's this. It's when you have this many of something. Okay, and you guys don't need to write this long number down. That's a lot of zeros. Okay. So based on what we just talked about, so if you have a dozen donuts, you have 12 donuts. But if you have a mole of donuts, you have this many donuts, okay? If you have a pair of shoes, you got 2 shoes. If you have a mole of shoes, you have this many shoes. So the point is, a mole is a way for us to count a lot of things at one time. Okay, atoms are really small. You can't even count them 100, 1,000, even a billion or a trillion at a time. You have to count them 1 mole at a time, okay? So that's pretty much what the concept of a mole is. Any questions on that? Was that all right? Yes. Yeah, so this gets kind of beyond the scope of this class, but we based it off how much carbon weighs. So carbon is like the standard, and then when we use carbon as our standard, it ends up being 6.02. Yeah. So, but don't worry about it. If you take AP Chem with me, then we can talk about it, but it's not too relevant for this class. Just trust me on that. All right, good question though. All right. Just for reference, that number is called Avogadro's number, but we're not really going to talk about it. Okay, and we use it to count atoms because they're so small. We got to count them this many at a time. All right, so let's get into the actual skill for today. So I want you guys to write this term down, molar mass, and that's the title of today's lecture. Molar mass is the mass or the weight, or you can consider it the grams. How many grams are in 1 mole of something? So every element has a different weight to it. Some of them are bigger, some of them are smaller. And so if you have a different number, or if you have 1 mole of different elements, they all weigh a different number. And you can find the molar mass of an element by looking at the number on the bottom of the box on your periodic table. Okay, so that's the number we haven't talked about yet. But the number on the bottom of the box is going to tell you how much 1 mole of that element weighs. So here we have xenon. So 1 mole of xenon is going to weigh 131.293 grams. That's what that number means. If you take a look at hydrogen on your periodic table, the number on the bottom of the box for hydrogen is 1.01. So 1 mole of hydrogen is going to weigh 1.01 grams. Okay, that's pretty much what that number means. It's the weight of 1 mole of that element. Any questions on that? Okay, so I want you guys to go to the periodic table. We'll do a quick question. I'll give you guys like 30 seconds to find phosphorus. It's on the right side. And I want you guys to write down on your paper, what is the molar mass of phosphorus? This is our first example problem. Okay. Take like 30 seconds to write down the molar mass of phosphorus. It's on the right side of the periodic table. All right, guys, so if you take a look at the periodic table, on the right side, we have phosphorus. And you should be able to see that the molar mass of phosphorus is 30.97. Everybody got that? Okay, so the answer is 30.97. But going forward, you can never write a number just by itself because we're going to be using a lot of different numbers and a lot of different measurements. So we need to specify what this 30.97 means. So whenever it comes to molar mass, whenever you find the molar mass of something, you write the number, and then the unit of measurement, the way we describe it is grams per mole. Okay, so you have to add this G/mole. It's just telling you grams in 1 mole. That's what this means right here. Okay, this part right here just means that there are 30.97 grams in 1 mole of that compound. Let's just make sure you write G/mole. All right, so we just went over how to find the molar mass of all the elements, right? It's just a number on the bottom of the box. I showed you guys how to write the answer, right, in terms of the number and the unit of measurement. Now what we're going to do is we're going to take a look at how to find the molar mass of molecules, okay? So not just elements by themselves, but when they combine together to make molecules, we're going to find how much 1 mole of different molecules weigh, okay? So what I want you guys to do is take a second to copy down this equation. It's already balanced for you. So just take maybe a minute to copy this down. And I'm going to show you guys how to find the molar mass of every single molecule in there. So we're doing 4 examples just to kind of get you guys started. Hopefully you get a good understanding of it. But take a minute to copy this down. And then I'm going to start going over how to find the molar mass of all the molecules in there. Okay, so if you guys take a look at this equation, you should see that there are 4 different molecules, right? The first molecule is this one right here. So the first molecule is CH4. The second molecule is O2. I know there's a 2 in the front, but that's just telling you need 2 moles of O2. The third molecule is CO2. And then the last molecule is H2O. So there are 4 different molecules inside of this equation. And what we're going to do is we're just going to work together to figure out how much each of these weigh. What's the molar mass of all of these molecules? And you don't add them up or anything. We're looking at them separately. All right, so let's start with CH4. So if we want to find the molar mass of a molecule, all we have to do is figure out what it's made out of, find out how much the components weigh, and then just add them up. So let's start with CH4. So first element in there is carbon. How many carbons are inside of CH4? Yeah, just one, right? There's no number behind it. So if we just kind of extrapolate this, there is one carbon. So I'll just do C and then times one just to show there's one carbon. Okay. The other element in there is hydrogen, right? And how many hydrogens are in CH4? 4. Okay, so CH4 is made out of one carbon and 4 hydrogens. Okay. So far, so good on that? Okay, so if we want to find the molar mass of CH4, all we have to do is find out the molar mass of all the things that make it up, and then just add it together. So let's start with carbon. If we go to the periodic table, and we look for the molar mass of carbon, you guys should see carbon has a molar mass of 12.01. So we can copy that down onto our paper. So the carbon inside of CH4 is going to weigh 12.01 grams per mole. That's how much weight the carbon contributes. Let's take a look at the hydrogen. Hydrogen on the periodic table tells us that the molar mass is 1.01. So the molar mass of hydrogen is 1.01. So far, so good, guys? Okay, now, there's 4 hydrogens, so we need to make sure that we account for all 4 of them. So we just multiply this by 4, and that'll give us 4.04. 1.01 times 4, that's what we get. All right, so if we want to find the molar mass of the entire molecule, all we have to do is add them up. It's just super easy. So we'll pull out our calculator, 12.01 plus 4.04. And so the molar mass of CH4 is 16.05 grams per mole. Okay. And that is how you find the molar mass of molecules. Super simple. All you need to do is find it on the periodic table, and then make sure you multiply by the correct number and just add them all up together. Any questions? Easy peasy? Okay, so I'll give you guys about 4 minutes. See if you can work with the people next to you and do the remaining 3 molecules. Find the molar mass of CO2, O2, and H2O. And then we'll try a harder one after that. But let's see if you guys can get these 3 on your own. Okay, so take about 4 minutes to do that. Okay, so let's start with O2, just because it's super easy. If you look at oxygen on the periodic table, the molar mass of oxygen is just 16. So if there's 2 of them, 16 plus 16, and that'll give you a molar mass of 32 grams per mole. Okay. Any questions on that one? Okay, move on to the next one. So this one has 1 carbon, so that's going to be 12, and 2 oxygens. So we just said that there's 16 each. Sorry, 12.01. And so 12.01 plus 16 2 times, you should get 44.01 grams per mole. Any questions on CO2? Yeah, so 12, 16, and 16. All right, and then the last one for H2O, we're going to take the hydrogens. There's 2 hydrogens, so it's 1.01 plus 1.01. The oxygen is 16, so you add 16 to that. So H2O has a molar mass of 18.02 grams per mole. All right, so that's all 4. So if you guys got all of the 3, then you're in pretty good shape. We're going to do a harder one after this, but any questions on this one? Not too bad? Alrighty, so this one's nice because we're working with very small numbers and the molecules are pretty small, but sometimes we work with molecules that are a little bit bigger. And the more interesting chemicals are the ones with bigger molar masses. So we're going to take a look at methamphetamine now. Okay, so the chemical formula for methamphetamine is right here, C10H15N. Okay, so I want you guys to take about 3 minutes. You can work with the person next to you, see if you can find the molar mass of meth, and then we'll double check our answers. And this is about as big as the molecules are going to get going forward. This is probably one of the harder ones. So take a second to try it out, and then we'll go over the answer together. Alrighty, so let's start with carbon. So if we take a look at meth, meth has 10 carbons inside of it, right? And then you should have seen on the periodic table that carbon is 12.01 grams per mole, and there's 10 of them, so we just multiply that by 10. Okay, so all of the carbons inside of meth, they'll give you guys a total weight of 120.1. Okay. We take a look at the hydrogens. Okay, you should see that hydrogen is 1.01 grams per mole, and there are 15 hydrogens. Okay, so that'll give you a molar mass of 15.15 altogether. And then you should see that there is nitrogen, which is 14.01, and there's only one of them, so it's just 14.01. Okay. And so if you want to find the molar mass of the entire molecule, super easy, you just add them all up. So you get 120.1 plus 15.15 plus 14.01, and the final answer, 149.26. And make sure you guys write grams per mole. All right, so that's one of the bigger molecules. If you guys got that, great work. That's probably about as big as the molecules will get, about as hard as it'll get. Any questions on finding the molar mass of the bigger molecules? It's same thing, just bigger numbers, counting the elements. That's it. All right, so we do have one more concept we do need to go over before we close up. Like I said, today is a bit of a longer lecture. And what we're going to be doing now is we're going to be taking this information about molar mass, and we are going to be switching between grams and moles. A big part of chemistry is taking something in grams, turning it into a different way of measuring it, so moles, and then transferring it back and forth. So this process is called converting. So right now, what I'm going to teach you, again, just to summarize what I just said, I'm going to be teaching you guys how to take grams. Like if I give you 10 grams of something, you're going to be turning it into the opposite. So you're going to be turning it into moles, and vice versa. If I give you like 10 moles, you're going to be turning it into grams. Okay, that's what we're going to be going with. That's what converting is, just switching between units of measurement. All right, so we'll start with number 4 as our sample problem, and then I'll give you guys some time to try number 5. But whenever you have a problem, when you're switching between one and the other, you always want to start by figuring out what your starting number is, okay? So you always want to figure out what your starting number is. So make sure you jot this down. I'm showing you guys how to solve this problem. So when you're switching between grams and moles, always figure out what your starting number is. And then after that, you want to figure out what you want to end up with. So you want to figure out what you start with and then what you want to turn that number into. So if we take a look at this problem, you'll see that the only number that we start with is 1,000 grams. And so that is going to be your starting number, 1,000 grams. Yeah. To where? All right, so we start out with 1,000 grams, and then we want to turn it into, the question says, moles, right? We want to turn grams into moles. So we're going to write that as our ending. We want to turn this into moles. And whenever you're switching between grams and moles, what you do is you're going to have to use the molar mass of that chemical. Okay, so in this case, we're using the molar mass of meth, which we just figured out. I believe it was 149. Thank you. 149.26 grams per mole. Okay, so this is what we're going to use in order to solve this problem. You're turning 1,000 grams of meth, and you're turning it into moles of meth. You want to figure out how many moles are inside 1,000 grams of methamphetamine. Okay. All right, so I'm going to show you guys how to do it. It's super simple. Some of you guys might be able to look at this, and just figure out what the process is. However, I'm going to require you guys do it the way I show you, because next time we meet, we're going to be learning pretty much the main skill in all of chemistry. It's what you'll be using for the rest of the year. And if you learn how to do it this way, it'll help a lot next class. So please, even if you know a more efficient way of solving this problem, please do it the way I show you, because in the long run, it'll help you guys out. Okay. All right. So what we're gonna do is we're gonna just start by writing down our starting number. So 1,000 grams. Okay. And what we're going to do is we're going to set up a fraction. And again, I know that some of you guys might be able to figure out how to punch this into a calculator already, but you have to show this fraction if you want credit for the assignment, okay? I know it might be a little annoying, but it'll help you out in the long run, I promise. Okay. So you write down 1,000 grams and you set up a fraction. Now, whenever you're trying to get rid of something and turn it into a different unit of measurement, whatever you're trying to get rid of, so grams, you put it on the bottom of the fraction, okay? You guys remember from algebra, if you have something on the top and bottom of the fraction, they cancel each other out, right? So that's the concept behind that. So you want to get rid of grams, so you put it on the bottom of the fraction. All right, you want to turn it into moles, right? That's what you're looking for in this problem. So whatever you're looking for, you put on the top of the fraction. Okay, so again, whatever you start out with, whatever you're trying to get rid of, you put on the top of the fraction, or sorry, the bottom of the fraction. Ooh, tripping out. Okay, so whatever you want to get rid of, you put on the bottom of the fraction, and then whatever you want to find, you put on the top of the fraction. Okay. All right, now in this fraction, we're gonna put in the molar mass. Okay, now if you guys take a look at the molar mass, it's 149. And if you look at 149, it's right next to grams, right? And so what we're going to do is we're just going to put it next to grams. So 149.26 goes next to the grams. And then molar mass is talking about 1 mole of something. So we just put 1 on the top. Okay. All right. And so that's going to be our fraction. All we have to do is plug it into our calculator and we're all done. All right. So quick algebra lesson. Whenever you have a fraction multiplying with another number, the numbers on the top you're going to multiply, and the numbers on the bottom you're going to divide. Okay, so in this case, what we're going to do is we're going to punch into our calculator 1,000. Okay, there's a 1 on the top, but if we multiply by 1, it's the same number, so we can ignore it. So what you're going to punch in is just 1,000 divided by 149.26. And that's going to be your final answer. So the answer to this question is 1,000 grams of meth is going to be equal to 6.699 moles of meth. Okay. And that's pretty much all the new info for today. Today, you're just going to be practicing switching between grams and moles. And this will directly lead into what we learn next time, which again is the main skill for chemistry. It's the one, if I'm being frank with you, if you guys don't get, then I'll see you guys next year, okay? Which I would love. I would love to see all of you next year, but I'm sure you guys want to move on. Forget about me. All right. Any questions on this before we move on? Yeah. Yeah, it's always going to be 1 mole when you use molar mass. The molar mass, the fraction right here, it's going to change every time you do it. But whatever you start with, you just put it on the bottom of the fraction. You'll see in the next problem what I mean by that. All right, so let's move on to number 5. We have 2 more practice problems. I want to make sure that we get a lot of practice with this before you guys get started on your assignment. So I'll give you guys about 3-4 minutes. See if you guys can figure this out with the person next to you. I'll give you guys some help before you start. Again, figure out what your starting number is. Figure out what you want to find. And then you need to find the molar mass of this chemical right here before you start. Okay? So those are my hints. Take about 4 minutes. You can work with the person next to you, and then we'll go over it in 4 minutes. Okay, so if you guys take a look at the problem, our starting number is 0.25 moles. That part's pretty easy, right? Okay, so 0.25 moles. Now, I told you earlier that we're turning it into the other unit of measurement, right? So if we start out with moles, that means we're going to be turning it into grams. So we want to turn moles into grams. So it's the opposite of last time, right? In the previous problem, we turned grams into moles. This time we're turning moles into grams. Does that make sense? Okay. All right. Now, I told you guys before you guys started that you have to find the molar mass of this chemical. So let's find the molar mass of CaCl2. So if you go to the periodic table, Ca is 40.08. So 40.08. And then if you take a look at Cl on the periodic table, you're going to get 35.45. So 35.45 right there. All right. All right. Now, there's 2 chlorines. So we're going to add 2 chlorines together. So you just need to add up these 3 numbers in order to get your molar mass. So for the molar mass, it's going to be 40.08 plus 35.45, and then do that 2 times. And so the molar mass will be 110.98. Okay, and that's grams per mole. Okay. All right, so I'll pause right there. Any questions up to that point? That part's pretty easy? Okay. All right, so what we're going to do now is we're going to use the molar mass in order to turn moles into grams. So let's set up our fraction. So whenever you set up your fraction, I told you guys earlier, take your starting number. So your starting number is 0.25 moles. So 0.25 moles. And then you're going to set up a fraction. So we're going to set up one fraction like that. Okay, so if you guys remember, whatever you start off with is what you want to get rid of, right? Because you don't want moles anymore. You want to turn it into grams. So whatever you start with, you want to get rid of. So moles is something you want to get rid of. So whatever you want to get rid of, you put on the bottom of the fraction. That way they cancel out. Remember, just regular algebra. If you have something on the top and bottom, they cancel each other out. So if you guys want to make a real quick note before we move on, whatever unit of measurement you start with, you put it on the bottom of the fraction. Okay. Okay, so if you start off with moles, you put moles on the bottom. If you start off with grams, you put grams on the bottom. All right, and since you want to turn it into grams, whatever you're looking for, you put on the top of the fraction. Okay, so whatever you're looking for, you put on the top of the fraction. Okay. All right, now what we're going to do is we're going to take the molar mass right here and plug it into our fraction. Now, 110 is next to grams, right? Where's grams on this fraction, top or bottom? The top. So we want to put the grams on top this time because that's where grams is. And then it's 1 mole, so we put 1 on the bottom. And if we do that, again, if you have something on the top and bottom, they cancel out. So if you get rid of moles, whatever answer you get, you're going to get it in grams. Okay, so let's punch it into our calculator. Remember, all the numbers on the top you multiply, all the numbers on the bottom you divide. So 0.25 times 110.98. If you divide that by 1, it's still the same number. So your final answer here is going to be 27.745, and your answer is in grams. Okay, and that makes sense because that is what you are looking for. You're looking for grams. All right, so I know, again, that's a lot of stuff. There's a lot of steps, a lot of numbers. We're going to do one more problem together. So before we move on, do you guys have any questions on that part today? All right, so this is our last problem, and this time you're going to be finding out the moles of caffeine in my coffee every morning. So let's do the starting and ending, and let's see if you guys can set it up on your own. So if you guys take a look at the starting number, there's only one number, right? It's going to be 0.5 grams. So you're going to start this problem with 0.5 grams. And you want to find the ending after that. And so if you take a look at the question, it's asking you how many moles of caffeine you want to find. So you're looking for moles. Okay, so that's the starting and end point. Okay, I've given you the formula for caffeine. It's right here. So you'll have to find the molar mass, same as before. So I'll give you guys 3 minutes. Let's see if you can find the molar mass of caffeine and then set up the fraction on your own. Okay, so take about 3 minutes. see if you guys can figure out finish the rest of this problem with the person next to you. Take 3 minutes to do that. All right, so I gave you the molar mass of caffeine. Should have got 194.22. And so what we're going to do is we're going to take our starting number and set up our fraction. So 0.5 grams. Okay, we're going to set up a fraction. Since you want to get rid of grams, right? This is our starting unit of measurement. We put it on the bottom. So grams goes on the bottom. You're looking for moles, so you put moles on the top. Okay. And then we just plug in our molar mass. 194 is next to grams. So we put it next to grams on the bottom of the fraction. And then it's going to be 1 mole on the top. All right, so we can punch this into our calculator now, and we're all done. So 0.5, and then you divide by 194.22. And so you get your final answer, which is 0.00. And then let's just cut it off at 257. And the answer is going to be in moles. Yeah, when you're using molar mass, it's always 1 next to the mole. So this fraction right here is we get this information from the molar mass, right? This right here. And then if you remember, by definition, molar mass is 1 mole. How much 1 mole weighs? So the numbers you add up, it goes next to grams, and then 1 is always next to moles. Good question, though. All right, now, if you got something close to this, it's okay. So this is kind of my chance to tell you guys that going forward, you and I might actually get different answers. But as long as the numbers are similar, you still will get full credit for your answer. So what do I mean by that? Let's say, for example, you got 0.002, and then you round it up to 26. That answer is perfectly valid. You'll get full credit for that. Let's say, for example, that you just wrote 0.0025. That's also fine. If you put 0.002574, that's also fine. Okay, the reason why is because as we go deeper into chemistry, your calculators might round things differently than me. You might personally cut off numbers, but as long as you and I get a very similar answer, right? This isn't off by much. Okay, you will get full credit for your assignments and your quizzes going forward. So just keep that in mind. If you get something slightly different from me, it's not wrong. If you have a question about your answer, you can always ask me, but as long as it's similar, you should be fine. Yeah, what's up?